In 1888, Thomas Edison paid a man to travel the streets of New Jersey kidnapping dogs. Not for science, not for medicine, for a demonstration. A very specific, very deliberate, very public demonstration designed to terrify an entire nation into choosing his technology over his rivals. This is not the story of how electricity was discovered. This is the story of what happened when two geniuses decided that winning mattered more than anything else, including the truth. It starts, as most great stories do, with a single extraordinary idea. In the early 1870s, the world after dark was a different place. Cities were lit by gas lamps that flickered, smelled, and occasionally exploded. Candles were expensive. The wealthiest homes had arc lights, brutal, blinding carbon electrodes that bathed entire streets in harsh white glare, but were far too intense and far too dangerous for indoor use. The concept of a warm, gentle, controllable light source that could be switched on in a bedroom or a kitchen or a factory. That concept did not exist. Thomas Edison decided it would. In 1876, Edison established his now legendary research laboratory in Menlo Park, New Jersey. He described it as a machine for producing inventions, and it functioned like one. Teams of researchers worked around the clock on systematic trial and error at a scale no individual inventor had ever attempted. Edison himself was already famous. He had invented the phonograph. He had improved the telegraph. The press called him the Wizard of Menlo Park, and he cultivated that reputation with the precision of a modern public relations strategist. In 1879, after more than a year of testing over 1,000 different materials for a filament, Edison demonstrated the first practical incandescent light bulb. The filament was carbonized bamboo. The bulb glowed for over 13 hours. Reporters were invited to Menlo Park and watched in amazement as Edison lit street after street with steady, warm electric light. The world changed that night, and Edison knew it. He did not just invent the light bulb, he invented an entire system around it. Generators, distribution networks, meters to measure usage, junction boxes, fuses. Every component of what we would now recognize as an electrical grid was designed, tested, and patented by Edison's team. By 1882, he had built the world's first commercial power station on Pearl Street in Lower Manhattan, supplying direct current electricity to 59 customers. Direct current, DC. This was Edison's technology, electricity that flows in one direction only, steady and constant. It worked. It was reliable. Edison understood it completely and had bet his entire commercial empire on it. But DC had a problem, a fundamental physics-level problem that Edison knew about and did not want to discuss. Direct current cannot travel far. The further it travels along a wire, the more energy it loses to resistance. By the time DC electricity had traveled more than roughly a mile from its source, it was too weak to be useful. This meant that to power a city with DC, you needed a power station approximately every mile. In the dense, wealthy blocks of Lower Manhattan, where buildings were close together and customers could afford the service, this was manageable. But for the rest of the country, for rural areas, for smaller cities, for anyone who was not within walking distance of a Pearl Street, Edison's system was economically impossible. Edison knew this. He had no solution, and he was running out of time. In 1884, a 28-year-old Serbian engineer named Nikola Tesla arrived in New York City with a letter of introduction from his former employer, Charles Batchelor, who had worked closely with Edison in Europe. Batchelor's letter reportedly contained a line that has since become one of the most repeated sentences in the history of technology. It read, "I know of two great men. One is you. The other is this young man." Tesla was unlike anyone Edison had encountered. He had photographic memory. He could perform complex calculus in his head. He spoke 8 languages. He claimed to be able to visualize mechanical inventions so precisely in his mind that he never needed to draw blueprints. He could simply run the machine in his imagination until he found the flaw, and then fix it before building anything. He also had an idea that Edison's entire system was built on the wrong foundation. Tesla had been working for years on alternating current, AC. Unlike direct current, which flows in one direction only, alternating current reverses direction many times per second. This oscillation, which sounds like a flaw, is actually an extraordinary advantage. It allows voltage to be stepped up or stepped down using a device called a transformer. Step the voltage up very high, and the current can travel enormous distances along a wire with minimal energy loss. Step it back down at the destination, and you have safe, usable electricity delivered across hundreds of miles from a single generating station. Where Edison needed a power station every mile, Tesla's AC system needed one every few hundred miles. Tesla joined Edison's company and worked there for nearly a year, improving Edison's DC systems and motors with impressive efficiency. The two men could not have been more different. Edison was a self-taught pragmatist who believed in exhaustive empirical testing. Tesla was a trained theorist who trusted mathematical intuition. Edison worked by trying everything until something worked. Tesla worked by understanding the underlying principles so completely that he often knew the answer before running a single experiment. The relationship deteriorated. Tesla claimed Edison had promised him $50,000 if he could successfully redesign and improve Edison's DC generators, a task Tesla completed, saving the company an estimated $80,000. When Tesla asked for the money, Edison reportedly laughed and told him he did not understand American humor. Tesla resigned the next day. This was not merely a professional dispute. It was the moment that set the course of the next decade. Tesla went to work with George Westinghouse, a Pittsburgh industrialist and inventor who had already built an empire selling air brakes for railway cars and immediately understood the commercial implications of AC power. Westinghouse licensed Tesla's patents, paid him generously, and began building AC power infrastructure across America. And Edison, watching his commercial empire threatened by a superior technology he had dismissed and publicly mocked, made a decision that would define his legacy in ways he never intended. He decided to destroy alternating current, not with better engineering, with fear. Edison hired Harold Brown, a self-described electrical engineer with no formal training, and together they launched what historians now call the War of the Currents, a deliberate, systematic propaganda campaign designed to convince the American public, regulators, and legislators that alternating current was uniquely, lethally dangerous. This is where the kidnapped dogs come in. Edison opened his Menlo Park laboratory to public demonstrations in which stray animals, dogs and cats collected from the streets, were placed on a metal plate connected to a Westinghouse AC generator and electrocuted in front of audiences. The message was explicit. This is what AC electricity does. This is what Westinghouse wants to put in your walls. The demonstrations were effective theater. They were also deeply misleading. DC electricity at sufficient voltage is equally lethal. The difference was not that AC was more dangerous than DC. The difference was that AC could be transmitted at high voltage over long distances. The danger that Edison was demonstrating was a function of voltage, not the type of current. But that distinction was deliberately obscured. The campaign escalated. In 1888, New York State was searching for a more humane method of executing condemned prisoners than hanging. Brown and Edison, quietly, without public acknowledgement of Edison's involvement, lobbied successfully to have the electric chair constructed using Westinghouse AC generators. When Westinghouse refused to sell his equipment for use in executions, Brown obtained Westinghouse generators through intermediaries under false pretenses. The first execution by electric chair took place in 1890. The device was initially called the Westinghouse. Edison's allies in the press suggested that being executed by electricity should be referred to as being Westinghoused. Westinghouse was furious. He understood exactly what was happening. In newspaper interviews, he methodically dismantled Edison's safety claims with engineering data. He pointed out that DC at high voltage was equally lethal. He noted that every death attributed to AC electricity was the result of improper installation or operator error, the same causes that produced DC fatalities. He hired engineers to calculate the precise voltages at which both current types became dangerous to human tissue and published the results. The data was on Westinghouse's side. It had been from the beginning. But Edison had something Westinghouse did not. He had the public's imagination. He was the Wizard of Menlo Park. His name meant electricity. And in a world where most people did not understand volts and amps and alternating frequencies, the image of a dog dying on a metal plate was more persuasive than any engineering specification. The turning point came in 1893. The World's Columbian Exposition, the Chicago World's Fair, was the largest public event in American history to that point. Organizers wanted to light the entire fairground with electricity. Both Edison's DC camp and Westinghouse's AC camp submitted bids. Edison bid $1 million. Westinghouse bid $399,000. Westinghouse won. On the night the fair opened, 200,000 light bulbs illuminated the grounds simultaneously. The crowd was silent for a moment, and then erupted. Many people attending had never seen electric light before. They wept. They reached out to touch the bulbs to see if they were hot. Journalists wrote that the fair looked like a dream, like a city from a future century, like something that should not have been possible. Tesla stood at the center of it. He gave demonstrations in which he passed hundreds of thousands of volts of AC electricity through his own body, generating glowing plasma and lighting lamps held in his bare hands, unharmed. He was already becoming a legend in his own right, not the cautious, commercial legend that Edison had cultivated, but something stranger and more electric. The fair was the beginning of the end for DC as the dominant system. The following year, Westinghouse won the contract to harness the power of Niagara Falls, the largest hydroelectric project ever attempted. The generators used Tesla's AC system. The electricity they produced traveled 26 miles to Buffalo, New York, lighting an entire city from a single remote generating station. It was a proof of concept that no amount of animal electrocutions could refute. Direct current did not disappear overnight. Edison's Pearl Street station continued to operate. DC systems remained in place in dense urban areas for decades, but the infrastructure of the modern electrical grid, the system of high-voltage transmission lines, transformers, and distribution networks that powers the world today, was built on Westinghouse and Tesla's alternating current. Edison almost never spoke of Tesla again after their falling out. In his later years, when asked if there was anything he regretted, he did not mention the War of the Currents specifically. But he said he wished he had spent more time on mathematics. The comment was pointed enough that most historians have understood it as a quiet acknowledgement of where he had been wrong. Tesla's story ends differently and darker. After his work with Westinghouse, Tesla pursued increasingly ambitious projects: a wireless power transmission system, a global communications network, experiments that he claimed could transmit energy through the Earth itself. He was brilliant, and he was visionary, and he was almost entirely unable to translate vision into commercial reality without a partner who understood business. Westinghouse had been that partner for a time. He would not find another. By the early 20th century, Tesla was broke. His laboratory in Colorado had been abandoned. His great project on Long Island, Wardenclyffe Tower, designed to transmit electricity wirelessly across the Atlantic, was demolished by its financiers when the money ran out. He lived in a series of New York hotel rooms, feeding pigeons from his window, growing increasingly isolated. He died alone in 1943 in room 3327 of the New Yorker Hotel. He was 86 years old. He had no heirs. His estate was valued at less than $1,000. 3 days after his death, agents from the Office of Alien Property, a wartime government agency, seized all of his papers, notebooks, and personal effects. Many of those documents have never been fully released to the public. Edison had died 12 years earlier, in 1931, surrounded by his family, his legacy already cemented. His name is on a major American electricity company to this day. The man who gave the world the system it actually uses, powered down quietly, alone, and largely forgotten. What the War of the Currents shows us is not simply that the better technology won. It shows us something more uncomfortable than that. It shows us that, in the space where genius meets ambition, where invention meets commerce, where truth meets the desire to win, the story does not always end in proportion to the contribution. The light you turn on tonight runs on alternating current, on Tesla's mathematics, on Westinghouse's investment, on a system built by a man who died in a hotel room with less than $1,000 to his name. And the name on the wall socket in most of the world is still Edison. If this video made you see history differently, leave a comment below and subscribe for more videos that challenge everything you thought you knew.